Every time you swipe a card, request a loan, or split a dinner bell, an unseen architecture makes the decision. The mechanisms deciding who gets money and how fast operate entirely out of sight. For years, companies like Stripe, Block, and Revolut treated artificial intelligence as an experimental side project. Now they have quietly reclassified it. AI spending has shifted into the permanent infrastructure category, alongside server farms and payment networks. This chart shows the scale of that shift. By late 2025, among financial technology companies generating more than $10 million a year, over 71% run their platforms on a foundation of integrated AI. AI has evolved into the invisible current powering every internal system. Without these models running 24/7, the platform's core functions, from fraud detection to liquidity management, simply stop. Legacy apps rented AI, sending data outward via API calls. This external architecture is obsolete due to privacy vulnerabilities and latency. Top-tier fintechs now deploy proprietary models inside their secure internal perimeter, processing thousands of variables and executing decisions in under 50 milliseconds. At that speed, legacy programming fails. A static, rules-based engine, like a hard code flagging any foreign transaction over $500, simply cannot compete with a localized model executing contextual math in milliseconds. Traditional banking runs on relational databases. In that system, a user's entire financial life is reduced to a static ledger of rows and columns, dates, locations, and dollar amounts. The new architecture requires vector databases. A transaction history becomes a multidimensional map, charting complex behavioral relationships and risk variables that the AI navigates instantly. This spatial map enables multimodal ingestion. Instantly, the system reads raw text on a receipt, analyzes device metadata, and measures the physical cadence of how the user types, evaluating unstructured data simultaneously. By continuously ingesting these variables, the platform abandons the concept of a static password. Instead, it creates a passive biometric authentication loop, making user security an invisible, constant state. This localized intelligence gives the interface independent agency. Instead of waiting for a manual trigger, the system anticipates needs and executes maneuvers independently. This allows for predictive cash flow routing. If an app knows rent is due in 5 days and your paycheck just cleared, it can invisibly sweep the rent money into a high-yield sub-account, earn micro-interest for 4 days, and execute the payment precisely on the deadline, all without user input. Historically, chargebacks took analysts 90 days. Today, opposing AI nodes representing the merchant and consumer instantly cross-reference shipping logs and geolocation data. They verify facts and resolve the dispute in seconds. Real-time autonomous finance extends directly to borrowing. Concepts like fixed APRs are replaced by hyper-dynamic credit pricing, interest rates that fluctuate daily based on real-time macroeconomic indicators and your current cash flow. None of this functions without the underlying localized AI grid, but the complexity of that grid creates immediate friction with the law. Financial regulations strictly dictate that if a consumer is denied a loan or service, the institution must provide a clear, documented reason code explaining why. The core AI arrives at a decision by weighting millions of distinct variables simultaneously within a high-dimensional space. There is no single if-then logic chain to extract. Because the result relies on the aggregate interaction of these shifting weights, generating a human-readable reason is a functional impossibility. To comply with the law, the industry deploys secondary explainer AIs. They scan the primary model, converting the multidimensional math into legally compliant English text that human auditors can read. This translation layer introduces inherent legal risk. If the explainer AI misinterprets the core model's math, the company carries the liability for every hallucinated reason code provided to a regulator. Building and maintaining this localized AI power grid requires tens of millions of dollars in raw compute power, alongside highly specialized engineering talent. That capital requirement creates a sunk cost moat. Smaller startups can no longer easily disrupt the major players because they cannot afford to build their own infrastructure. They are forced to rent server space from third parties, destroying their profit margins. Traditional legacy banks face a different barrier. They possess the capital, but their institutions rely on isolated data silos and decades-old mainframe languages like COBOL. When older banks attempt to deploy AI, it functions as a bolted-on feature rather than integrated infrastructure. The legacy systems are too rigid to process the dynamic math, and the integration frequently fails. The financial sector has bifurcated. One group of companies owns and operates the new electricity, while legacy institutions attempt to wire a house that was never built to handle the current. Electricity is dangerous if the overarching system design is flawed. When the entire financial sector plugs into the same methodology, the risks scale with the speed. Major competitors like Stripe, PayPal, and Revolut all fine-tune their localized risk models on the exact same underlying foundational AI architectures. This creates algorithmic homogeneity. Because the underlying math is nearly identical, independent systems will inevitably develop the exact same blind spots to novel economic shocks. In the event of a sudden, unpredictable market anomaly, all of these independent AI models might arrive at the exact same defensive conclusion simultaneously, triggering an automated mass freeze of credit lines and transactions. While AI micro-optimizes individual apps and individual users, homogenization of the underlying code creates precise conditions for a cascading, localized economic flash crash. That strict adherence to the math creates a final vulnerability, digital redlining 2.0. By relying purely on data, these models successfully strip away explicit human prejudice. However, they immediately introduce pattern matching bias. The AI evaluates thousands of seemingly innocuous variables. The specific time of day a user shops, or the distinct vocabulary they use, quickly become statistical proxies for assessing credit risk. Because the model is heavily optimized to mitigate financial loss, it can systematically deny credit or services to specific demographics, executing the discrimination without ever explicitly knowing a user's race, gender, or age. Fintech has successfully built a faster, hyper-personalized power grid for money. But to achieve that efficiency, the economy is now tethered to an opaque mathematical system we do not fully comprehend.